So Matthew did number 1. So negative 2m squared, he got by saying 2m minus 4m, right? What about the 8m? How did he get 8m? 5m minus negative 3. So if you need to rewrite it, that's like 5 plus 3, right? That's how we got to 8. And then same thing on the 1. 1 minus negative 3 is 1 plus 3, which is 4. So very good job, Matthew. Number 2. So we're adding like terms, right? So Sarah Avery did this one by saying 15 plus 2t squared was 17t squared. And then negative 6t plus 5t is negative t. And negative 7 plus 4 is negative 3. Very nice job, Sarah Avery. And then Brinkley did number 3 for us. So remember that when you multiply the bases, you add the exponents, correct? So 2 plus 2 was 4. That's how she got 21 x to the 4th. All right, what number is understood to be the exponent on this one? 1. So when you distribute here, when you multiply the x's, you add the exponents. 2 plus 1 is 3. And then the last one, you just bring the x squared over with the 3 times 4. Very nice job, guys. Brinkley did number 3, so very good job, Brinkley. All right, what about number 4? Number 4 is your ACT prep question. It should be very easy. This one is. All right, so it says to determine a student's overall test score for the semester, Ms. Lopez throws out the lowest test score and takes the average of the remaining test scores. Victor earned the following test scores in Ms. Lopez's class. What overall test score did Victor earn in Ms. Lopez's class this semester? So what do I do? Which one? 62. I'm going to throw out 62. And then what do I do with the remaining test scores? Add them together. And then divide by, what is that, 4? Okay. So how much did you get? 84.5? Y'all agree with that? Very nice. Very nice. All right, so that's your bell ringer for today. You should have your notes for the next unit. So anytime you're absent, you don't have to worry about getting anything. You've got everything you need. You'll just go on the Google Classroom and watch the video, okay? All right. So let's look at our learning targets first of all. The very first thing that we are going to talk about is we are going to determine if the relation is a function. Okay. All right, what are we going to do after we determine if it's a function? What's the next one, guys? One-to-one or onto, right? And then the final one we're going to do today is evaluate functions. Okay, so it should be pretty easy. Our test will be Alright, so some of these numbers on the bottom of your pages got a little messed up. So obviously this is page 1, so if you can't tell that on your page, then you may want to fix that, okay? But some of them did get a little messed up. Alright, so here we go. We got a little bit of vocab, not much. So a blank is a set of ordered pairs. Not a function. Start with an R. Range. Not range, relation. So like you have relatives, right? Your relatives are a set of people. So a set of ordered pairs is a relation, okay? Alright, the next one. The blank is the set of x coordinates. What's the x coordinates called? Starts with the D. Domain, very nice. And then now we have the range. The range is the y coordinates. Alright, now Gracie, what is a relation in which elements of the domain is paired exactly with one element of the range? That's a function. There you go. Alright, so just like, do you remember how we started off the last unit with the real and the irrational and the integers and all that good stuff? Remember how we had that chart we always look back at? So this is that chart that you need to look at and look back at for when we're doing functions, okay? Alright, so let's look at number 1. Pretty easy. State the domain and range of each relation Why is it a relation? Because there are 1, 2, 3, 4, 5 sets of ordered pairs, okay? So, what's the domain? Domain are the x's. Now, for some people, especially when I first started learning this, it may still help you to write x and y above them. Some people do not need to do that. So if you don't need to do it, then don't do it. So what are my domains? -6, -5, -3, -1, 6. Now, is 6 the same thing as -6? No, it is not. All right, what else does it say? It says state the range. So what's the range? The range of the y values. -1, -9, -7, +7. Oh, you don't write it twice, right? We already have a -9, so we're going to stop it right there. We already have the -9, so we're not going to write it again. All right, then it says determine whether each relation is a function. So let's determine, is this a function? So do we remember what a function was? What could not repeat? To be a function, something could not repeat. The x values or the y values? The x values could not repeat. So you may want to make yourself a note of that because that's very, very important. The x values cannot repeat. I don't care about the y's yet, but the x values cannot repeat. So, determine whether this relation is a function. Is this a function? Yes, it is. Why is it a function? No. I do have a number that repeats. My -9s repeat. I don't have any x's that repeat, right? I don't have any x's that repeat. All right, last thing it wants us to do is, if it is a function, which this one is, then we have to determine if it's a one-to-one, an onto, a both, or a neither. All right, so how do we figure that out? So let's look at this. So we know it's not neither because it is a function, right? So you don't even pick that one. So let's look at one-to-one. Each element of the domain pairs to exactly one unique element of the range. There's that word unique. What does that word unique mean? Just in general, if you're unique, what does that mean? You're one of a kind, right? So that means that none of our y values repeat. Did we have y values that repeat? Yes, we did. So it is not one-to-one. Okay? So if it's not one-to-one, and if it's not neither, and it can't be both, what's the only one left? Onto. Alright, so let's look at onto. Onto tells me that each element of the range corresponds to one element of the domain, okay? So in other words, see right here where you have C? You see how you have two arrows coming to C? Don't see that? That means that you have two separate domains, but they both go to the same range. So for example, look here. We have two separate domains, right? -5 and 6. But they both go to the same domain. Does that make sense to everybody? All right, so if you need to make yourself a note, you can put on this one that your range repeats on this one. So if you have a range that repeats, then that would be an onto. If you have a range that repeats, that would be an onto. If you have a range that repeats, that would be an onto. All right, let's look at number 2. Make sure you read everything again. What's the very first thing it asks us to do? State the domain and range. All right, let's do that real quick. This one's easy, right? It's already pretty much spelled out for us. What's the domain? Quick. 2, -1, -2, right? I don't write the -1 again. I do not write the 2 again. What about the range? -2. Come on. -1, 0, 1, 2. Be careful, 2 and -2 are not the same thing. I wish that negatives and positives were, because then my bank account would be lovely. All right, I can spend whatever I wanted. All right, is this a function or not a function? Because that's what it asks us next. Not a function. Why? There you go. I've got 2's that repeat, and I have -1's that repeat. So this is not a function. And if it's not a function, you don't have to label it. You can't label it because it's not a function. All right, let's look at number 3. Which one's my domain, my x's, and which one's my range or my y's? They don't tell me. Where the arrows are going is one thing, but what else? What about alphabetical order? Which one comes first in the alphabet? The domain, which is the x's, right? So this is x and this is y. Whatever comes first is your domain. So your domain is, what is that, 2, 4, negative 8? Okay, so we're good, right? None of those repeat? What about my range? What does that say? Negative 6, negative 12, and 14? Negative 4, yeah. Sorry, I wrote it, I just didn't say it. All right, function or not a function? Function. Why? No repeating x values, okay? Keep saying that to yourself. No repeating x values. Yes, ma'am. Does it?
Yeah.
Oh, it does. It does. I'm sorry. Thank you. I didn't see that. So it's not a function. Thank you. I did not even see that. Thank you, Sarah. That's not a function. Very nice job. All right, let's look at the next one. So go to page 2. And again, if you can't see that 2 at the bottom, then just fix it, okay? Some of the numbers got a little messed up. All right, this one's easy. What's the domain? Negative 3, negative 2, negative 1, 0, 1. Anything repeating? Nope. So that's, I'm good right there. What about my range? Everybody okay? All right, keep that first page handy, okay, so we can look back. So function or not a function? Function, because none of my x values repeat, correct? All right. What else did it ask us? I put my paper away. Hold on. All right. So it asked us, if it's a function, is it one-to-one, onto, both, or neither? Okay. So obviously it's not neither, right? So what do we have? What was one-to-one? One-to-one meant that I only had one domain with one range, right? Yes, ma'am. Number that isn't used. We don't have one. Oh, 8. Is that not on 8? It's not on 8, is that? I'm going to look at my paper instead of looking up there. You don't write that one. I can't see. The 8 is not used. When I looked at it too fast, it looked like that arrow was on the 8. That 8 is not used. Goodness, Sarah, you're just catching my mistakes left and right today, aren't you? I need to get my life together today. Alright, so let's look at this one-to-one function. So one-to-one function, that means one domain goes to one range, right? Okay, so do we have that? Do we have one domain going to one range? No, we do not, right? Because the 6, isn't that a 6? Is that what that says? The 6 has a 1 going to it, and it has a negative 1 going to it, so it's not one-to-one. Alright, what's the onto? Onto means that we can have repeating ranges, right? Okay, so is that what this one is? Yes, because the same thing as 6, so this is onto. Y'all good? Alright, let's remember that vertical line test for this next one. You ready? Vertical line test. So, the vertical line test, first of all, what does the word vertical mean? Up and down, okay? This word vertical means up and down, so if you need to make that note to yourself, go ahead and do that. Alright, so what's it mean? Do you see this dotted line? How many times does this dotted line hit the graph? Once, right? Is that allowed? Yes. So this is a function, okay? What about this one? No, because it hits it twice. So if it's more than once, it's not a function. If it's just once, it is a function. Everybody good? Alright, so let's look at number 5. Here we go. So it's the same thing, but it's a bunch of dots, okay? So don't let it freak you out because it's not a graph. Draw you a vertical line. How many dots does that one hit? 1. But it'd be better if I did a highlighter. That might be better so y'all can see it. Alright. That one only hits once, right? Where's another one? Look at this one. That one hits it twice, right? It hits at 1, 5, and it hits at 1, 2. So is this a function or not a function? Not a function. So do I even have to say if it's on to or 1 to 1 if it's not a function? No, I'm good, alright? Alright, so then we're going to evaluate. This one's really, really easy. You just got to be careful. So, number 1 says, first of all, how do we say this? Do we say f times negative 3? No. What's that? Close. It is. We put one little word. Jonathan? F of x. Very good. F of x. And this is g of x, right? So we say this f of negative 3. And number 2 would be g of 4, right? Okay, so how do I know which function to plug number 1 into? How do I know what to plug negative 3 into? What, G? Because of the f. So which one am I going to plug that into? F of x or g of x? F of x, right? Okay, so here we go. F of x was 3x minus 5. So f of negative 3 means that anywhere I see an x, I'm going to plug in what number? Negative 3. So I have 3 times negative 3 minus 5. And those PEMDAS are still killing you. They are still getting you. You got to remember PEMDAS. Which one do I do first? 3 times negative 3 is negative 9. Then minus 5, right? So how much is that? Negative 14. So how do we say this? We say this f of negative 3 equals negative 14. So what does that mean on my graph? Because f of x was the same as what letter? Ooh, it's been a minute, hadn't it? F of x is the same as what letter? Alright guys, look right here. It's equal, right? What are we normally used to seeing on this side? What letter? Y. So f of x is the same as what letter? Y. You might want to make yourself a note because that is very important. F of x is the same as y. Okay? So what does that mean that negative 14 is the same as? Y. Right? So let's talk about what this means. This means at negative 3, which is what value? The x value or the y value? The x value. So when, let's write this on the side. When x equals negative 3, then y equals what? Negative 14. Very nice. Make sure you understand how to read that, okay? Yes, Matthew?
That's what you have to write as an answer.
No, you can write this as an answer, but you've got to make sure you understand what it means. So we are going to write this on our notes every single time because I want to make sure you know what it means. Because in a minute, you're going to have to graph this. Not today, but in a minute, okay? All right, let's look at number 2. Number 2 says g of 4, right? Okay, so how do I know which one to plug that into? Because it's g, right? And I'm going to plug in 4. So here's what I want you to do. I want you to plug that in. Be careful of that square. And then I want you to tell me what it means when we get done, okay? So try that real quick. Let me pause this. Hold on. So Josh told us that we plugged in 4. 4 squared is 16. And then 2 times 4 was 8. So g of 4 equals 8, right? So what does that mean? The 4 is in the x place, right? So when x is 4, then y is 8. Very nice job, guys. Very nice.
Do you need to write that with x before?
You don't need to write it, no, but I am going to ask you what it means constantly. So make sure that you understand what it means, okay? All right, so make sure, let's see, that's our answer. That's our actual answer. All right, what? That is, I can't remember her name. Miss Billing. Miss Billing. She is one of our new assistant principals. Just because my door's open. That's all. Oh, wait, hold on. Oh, number 3. Here we go. So, number 3 is a little different. And number 4 is a little different. This is page 3, by the way, so if you can't see the page number, just fix it at the bottom. It's page 3. Don't let it freak you out. It's the same exact thing. So what am I going to plug into? F of x or g of x? F of x. So y'all help me out. What was f of x? It's on my other page. 3x minus 5? Okay. So look, guys. what am I going to plug in this time? A. So instead of x, I'm going to plug in a, right? So what do I get? Okay, don't let it freak you out. That's it. That's all you're doing. All right, what about this one? What was g of x? X squared minus 2x. Okay, same thing. Plug it into g of x. So be careful. Do I use parentheses or do I not use parentheses when I plug in for x? If I don't use parentheses, what is this telling me? This is only telling me the n squared, right? I need both of them squared. So yes, you do need to use parentheses. Same thing here. You've got to use parentheses because if you don't, you're only telling me 2 times 5, not 2 times 5n. All right, so what's this give me? What's 5n squared? 25. N squared, very nice. Very good, very good. Mike, you just stretching, you got a question? Say that again? Yes, it would. But it would not if this was, if it said 2n, sometimes y'all want to say 10n, like, y'all want to write it funny if you don't put parentheses. So just make sure you put parentheses. All right, y'all good?
Yeah.
Okay, here we go. Y'all have 5 through 8. 5 through 8. And same thing, you've got 3 of them, right? So Gracie just tells me f of x, g of x, and h of x. It's just telling me I have 3 different functions. Okay? Alright, y'all try those 3. Be careful, don't let those fractions get you. So let's look at 5, okay? Because 5 is getting y'all. So we're going to plug into g, right? Guys, look, g does not have parentheses. So what's the only thing that's squared? The x. That's it, not the negative 2. Okay, so several of y'all tried to square the negative 2. So it should look like that, okay? Negative 2 and then negative 6 squared. Negative 6 squared is what you do first, which is positive 36, right? When you plug it in your calculator, you also have to use parentheses. Then what's negative 2 times 36? 72. So what does that mean? That means when x... Oh, it is negative 72. Thank you, Matthew. So when x is negative 6, y is negative 72, right? Good? All right, what about 6? What did you get? Negative what? Yeah, that's what I got too. Hold on, let's work it out. So you plug it in, right? And only the x was squared, not both of them were squared. So you're going to do the 3 first, which is 9, and then that's 6 plus 5. Make sure you multiply. That's negative 36 minus 6 plus 5. So then you can plug all of that in your calculator. So negative 36 minus 6 is, and then plus 5 is negative 37. Y'all good? Alright, these fractions get you? What? Y'all haven't tried it yet? Okay, y'all try it real quick. Oh, this is an easy one. This one's not a bad one. That one's super easy. Alright, I'll give you a minute. Finish that one up, and then we'll do 8 together. So the 3's cancel out, so it'll be 2 plus 2. Alright, so what's that mean? When x is 2/3, then y is 4, right? Alright, so let's look at number 8. Let's see what h was. Let me scroll it down. Alright, y'all get that? Okay. Now, 1/5 squared, what does that mean? That means 1/5 times 1/5, which is how much? Bless you. 1 over 25. There you go, 1/25. Same thing. Alright, and then how do I say negative 4 times 1 over 25? You just divide them, right? Negative 4 over 25 minus 2 over 5 plus, I'm going to put that 5 over 1, okay? So how do I add and subtract fractions? find the greatest common denominator, right? So what's the biggest denominator that goes into all of them? 25. So to make this one 25, I'm going to multiply by 5. To make this one 25, I'm going to multiply by 25. This one wasn't so bad. Biggest. Alright, so this one just brings it down, right? This one is 10 over 25. This one is 125 over 25, is that right? Alright. I made 3 mistakes today, so I just got to make sure I can still multiply. Alright, then once your denominators are the same, you just say negative 4 minus 10 plus 125. How much is that? 111 over 25. And we can make that as a mixed number, right, if we want to. So let's see, h of 1/5 equals 4 and 11 over 25. Very good. Because I do not think that was a terminating decimal. Was 111 over 25 a terminating decimal? I don't think that's a terminating decimal. And it stopped? Okay. All right, I could have used a decimal then. But you still need to know how to do it for when it's not. What's wrong, Matthew? You sure? Positive? Okay. All right. All right, and then I think page 4 was a blank page, so I don't think you have a page 4. Then it should jump to page 5. So let's make sure that's right. Okay, so page 4 is not there, so we're going to go on to page 5. Alright, so let's just do this just a little bit, and then we will call it a day. And y'all can get your homework and have like 2 minutes to start on that. Alright, so here we go. Relations, so we're starting a new lesson, right? 2-2. Relations that have a straight line graph are called what?
Linear.
Yes, they are called linear. Where's my... Oh. Very nice job, Scotty. Alright, where are we at? Relations that are not linear are called nonlinear. Wow, this is really difficult, isn't it? Oh, no, it's killing me over here. Alright, so here we go. An equation such as x plus y equals 5 is called a linear equation, okay? Everybody good there? Alright, why is it called linear? Because x is to what exponent? 1, and y is to what exponent? 1, and you are adding, right? Do you remember that equation, y equals mx plus b? Alright. What? Y equals mx plus b?
Where did you get x?
Right here, baby. The x has an understood exponent of 1, right? The y has an understood exponent of 1. Oh. There is a 1 in front of x, but also you need to look at the exponent, because remember a parabola? Remember those? Remember that parent graph was y equals x squared. Ooh, we're going to have to go over our parent graphs, aren't we? We spent every, 6 tests on that because y'all could not remember them. Alright, so, actually, let's pause. Let's finish this out, and then we'll pause, and let's go over our parent graph, and let's also go over our perfect squares, because you will have a perfect square test on Friday. So, get ready for that. So, let's finish this out. A blank has no operations other than addition, subtraction, and multiplication of a variable by a constant. Okay, let's look at that. No operations other than addition and subtraction, right? You see the addition? And you could also have subtraction, like you could also have y equals 1/2 x minus 3, right? You see the addition and subtraction? Do you remember this? Alright. What does multiplication of a variable by a constant mean? 1/2 times the x, right? Or give me another number. 12x plus 7, right? So you're still adding or subtracting the 7, and the 12 is your constant times the x. Everybody okay with that? Alright. So the variables, wait, I didn't answer this, did we? A linear equation. Why is it an equation? Because they have equal signs. A linear equation has no operations other than addition and subtraction, which is what we have, and multiplication of the variables times the constant. All right, last one. The variables may not be multiplied together or appear in a denominator. So what does that mean, appear in a denominator? It can't be like this, right? Ooh, that was that very last graph you were supposed to learn in Algebra 1. Those were not the steps. They looked like this. We're going to go over it, don't worry. Do you remember those?
Yeah.
That's what the variable in the bottom is, okay? Don't worry for those of you that didn't learn this, or for those of you that are freaking out because you don't remember it. We will go over this every thinking day, okay? All right, so let's finish this out. So the variables may not be multiplied together or appear in a denominator. So you can't have the denominator like this, right? You also can't have x times y, is what it's saying. Everybody good there on what it says? All right, let's keep going. A linear equation does not contain variables with exponents other than 1. So you cannot have an exponent that is a square or a cube. So good? All right. And then it says the graph of a linear equation is always if it's a straight line. There you go. Very nice. All right. Here's what we're going to do. We are going to do two things. First of all, we are going to go over all of our parent graphs. So grab yourself a piece of paper, and I want you to title it parent graph, because we got to go over this. Grab yourself a piece of paper. We got to go over our parent graph. Guys, we're going to beat this into your head. Okay? Sketching graph, you don't need to have anything pretty. Just sketching it. Alright, here we go. You ready? Parent graphs. What was the very first graph you ever learned since middle school?
X equals something.
You have not learned x equals something yet. You've learned y equals something. The very first thing you learned to graph, we just went over it. Mx plus b, right? So you learned that the parent graph was y equals x, right? Because this was y equals mx plus b. And my m in this case is 1. And my b in this case is, really? 2? 0, people. Lord have mercy. This is why we're going over this. Lord Jesus, help me. Alright, what did the graph look like of y equals x?
A straight line starting at 0.
A straight line going through the origin, right? And make sure you put the arrows on the end. Starting at 0, and then you go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Alright, let's look at the next one. What about that one? What did that one look like? By the way, for those of you maybe that didn't learn this, parent means original, right? So this is the original graph. That's what parent means. What was y equals x squared? A parabola. Very nice. A parabola. Not cool. A parabola was a U-shaped graph, right? And it should have a vertex at 0, 0, at the origin. Just bringing back some memories to you. Lord have mercy. It better if you had me for algebra. Alright, what about this one? Well, we just talked about these. What are those?
Absolute values.
Absolute values. Very nice. So remember V for value? V for value. So what kind of graph did it make? A V. And it should also have a vertex at 0, 0. Lord have mercy. We're going to go over them every day. Do not worry. Okay? Because you've got to know these. Alright, next thing that you learned should have been the square root graph. So guys, square root is very similar to which one that we've already just talked about? X squared, right? How do you get rid of a square? You square root it, correct? Okay? So that means it's going, It's turned sideways, and it's only half of it, right? Why is it only half of it? Because you cannot have negative square roots. So that's why you're not going to have the bottom piece down here. You cannot have negative square roots. Alright, it kind of looks like a skateboard ramp. Then we learned, the last one we learned was 1 over x. It was the very last quarter, like the last couple of weeks of school. I know. We just went over it, though. It's the funky looking one. It's got this piece up here. It's got this piece down here. This is where you learn about asymptotes. Remember that funny word? Asymptotes. It had a vertical asymptote here, and it had a horizontal asymptote here. Just kind of sort of bringing back some memories a little bit. Alright, last thing before we leave. If you didn't learn this, don't worry. I got you. I got you. That's why we're going over it now. Okay? So why is it important to know this? This is very important for when you get on the ACT. We're not finished yet. So, when you get on the ACT, and let's say you have a crazy graph that you don't know what it looks like, but let's say all of your answer choices, let's say you have an absolute value graph as an answer choice. You know that's not the answer because you know this is supposed to be absolute value, right? Let's say you have this as an answer choice. You know that's not an answer choice because it's supposed to have a variable in the denominator, right? Does that make sense? Alright. Okay, so let's do our perfect squares. Let's do it down the side. What's the first one? Quickly. 1. Well, technically it is 0, but I'm not worried about that one. What's the next one? 4. 9. 16. 25. 36. 49. 64. 81. I gotta move my paper up. 100. 121. 144. Oh, let's say how good you are now. 169. 196. 225. Very nice. Alright, let's stop right there real quick. Hold on. We're going to have a quiz. This is 1 through 15, right? We're going to have a quiz on this on Wednesday on Google Classroom. You're going to have a quiz on Wednesday on Google Classroom, okay? It will be timed. So I want to make sure you know 1 through 15 first, right? And then on Friday, people, on Friday, you will have a perfect squares test. You will have a perfect squares test on Friday. So Wednesday is 1 through 15 quiz. Wednesday is 1 through 15 quiz. Friday is 1 through 25 test. Everybody good? Alright, so those should be pretty easy on Wednesday. Alright, let's go 16. What's the next one? 256. 17. 289. 18. 324. Very nice. 19. 361. We're at 20. Yep. That one's easy, right? What about 21? We only got 5 more. 441. 22. 484. 29. What are we at? 24, right? Ooh, we got 2 more. Nope, that's 25. 576. Very nice. Okay? You gotta know them. Why do you have to know them? Because when you see them, you must be able to recognize what it is, okay? What's your homework tonight? Workbook. Workbook. Page 13, numbers 1, 4, 7, 13, and 14. Page 14, numbers 2, 3, 6, 7, and 9. So you may want to get those out. You still have about a minute left. You got about a minute left, okay? If you want to take a picture of the board, that's fine. And it will be posted on Google Classroom tonight as well.